like it has a little fuse on everyone. It's just called that. I don't really get why. All right. So, factoring polynomials. Now, guys, this is the poster child topic for the people of the world that don't understand that being intelligent for the sake of being intelligent is worth it. Do you understand what I'm saying? I'm going to explain it again. This is useless in real life. Never in my 42 years have I been sitting down somewhere and thinking, holy crap, if only I could factor this trinomial, I would know what to do right now. Okay? Yes, Tavleen? But IQ tests are also useless. All they do is let you brag. Guess what? I'm a genius. According to IQ tests. Guess what? I'm not. Okay? So, back to business. Actually, I am, but I'm not. Because everybody who does poorly on IQ tests then goes and says, yeah, but I'm good at fixing cars or whatever, which is true, right? Then you get the people that aren't good at fixing cars, aren't good at art, aren't good at music, aren't good at writing, aren't good at reading, aren't good at math, they're good at nothing. And then somebody still says, but you're smart in your own way too. Which way is that? I don't know. But it's not true, because everybody has a talent. But people equate talent with intelligence, and that's not right. My view is you are intelligent if you can learn how to do something. If I chose to learn how to fix a car, I could learn how to fix a car because I'm an intelligent person. If I innately am good at looking at the engine of a car and figuring out where all the stuff goes, that's a talent that I happen to be good at. It's kind of like spelling. You don't get good at spelling in English from practice. You are good at spelling in English. It's a talent. You will all disagree because you all went through elementary school where you had to do spelling tests and you believed your teacher when they said that you were getting better at it. You weren't. Spelling is a talent. You know how to do it or you don't. I know. It's not your fault. Don't worry about it. It's a talent. Anyway, same with music. Everybody knows somebody who sat down at the piano the first time and played some Rachmaninoff. And you're like, wow, you're brilliant. You have an innate ability. Same reason there's NHL hockey players and fat guys on the weekend playing beer league. They all know how to skate. They all know how to put on their gear. Some are in the NHL. Some can barely get. Some need a defibrillator in the arena just in case. Or rugby, or baseball, or everything. It's all there. Like the whole world's belief that everybody is brilliant needs to go away. But that's beside the point. Where was I? Factoring polynomials. Totally useless, except in mathematics. Much like crossword puzzles are useless, but it makes your brain better. One of the things doctors say to do to make sure you don't turn into a vegetable when you get old is do crossword puzzles and Sudoku every single day. And yet, they are not going to help you in real life. And the people that run our province are like, why would you ever waste school time on something that isn't going to help them in real life? So anyway, this is that thing, right? We can do surface area problems and I can say, oh, we're going to paint our walls. Real life problem. We're going to do surface area problems. Oh, I've got to put grass seed down on my lawn. Real life problem. Before you get dinner tonight, you have to factor a trinomial. Doesn't happen. Okay? However, that being said, the people that do real life stuff, like put probes onto Mars and things, all know how to factor polynomials. And when they were 15, their teachers did not know they were going to be the people putting a probe on Mars. So they chose to learn how to do it just in case they ended up there. Which is really why you learn anything, just in case. I have a friend of the family who named their child Justin Casey Falls. Their last name was Fawls, and they named their child Justin Casey. Just in case he falls. Justin Casey. True story. Now, there are jokes like that, right? Like the Dover family who named their child Benjamin, right? Ben Dover. And then they had a sister and they named her Eileen. Yeah, that's not true. That's never happened in my knowledge. But I do know it just in case he falls. Yes. Yes. All right, back to business. So, what do I have here? I have two whats? Starts with a P, ends with an S, has polynomial in the middle of it. Two polynomials. Excellent. What is that one?
Coefficient.
It is indeed a coefficient, but it is also a monomial, yes? Okay, that is a monomial. You're a monomial. Yeah. And this is a binomial, right? If they were separate. Once we put them together, this becomes a coefficient. This becomes what we call a multiplicand, but never mind. And the whole thing is coefficient means this is all multiplied. And this will get us 4x minus 20. Why does it get us 4x minus 20? Because it is 4 times x minus 4 times 5, right? Distributive property. Everybody cool? This is what we call expansion. Now, when we go from the 4x, not 48, from the 4x minus 20, when we go back to 4x minus 5, this is what we call factoring. And all it is reversing our expansion. Now, what math happened when we were doing our expansion? Multiplication. So what math must happen if I am factoring? There must be division. Everybody cool? Yeah? Yeah, sure, you betcha. Okay. So what do I have here? Are these factors or a product? They're factors. How do you know that? Yeah, because they're going to multiply together. You have this binomial, and you are multiplying it by a second binomial. Now, what do we get there? Can I do the shortcut? What is it? X squared plus 6x plus 8. Yeah? And we remember 4 and 4 gives us the 6 and the 8. Right? Okay, everybody cool? This is expanded. This is factored. Yeah? All right, now we're not going to open up with this. We're going to do some easier factoring first. But we're going to do something with that by the end of today. The next thing I have to make sure you can do is I have to know that you can factor 12. Now, we have already done a bit of factoring, but we didn't do factoring. We did prime factoring, yes? In our earlier unit, when I said factor 12, you all went 2 squared times 3, yes? 4 times 3, right? That's what we did. That's not what we need to do now. Now we need to be factoring 12 means finding all the pairs that multiply to 12. So what are they? 1 and 12. What else? 2 and 6. What else? 3 and 4. How many people feel that we have them all? Do we have all of them? Do we have every pair of real numbers that multiplies to 12? I'm going to say it again slower. Do we have every pair of real numbers that multiplies to 12? I'm going to change one word. Do we have every pair of whole numbers that multiplies to 12? Yes. Do I have every pair of real numbers? No. Why? Because there's fractions that we can get to 12, isn't there? Okay? We don't care about the fractions, so you don't have to worry about them, all right? But what was the second thing I said? Every pair of whole numbers, yes? Whole numbers counts what? What are whole numbers? All the positives. Do I need to worry about negatives? Really? Because I see a negative right there that I needed to deal with, didn't I? So do I need to worry about negatives here? Yeah. So what else do I technically need here? If I were asking you to factor 12, don't I also need all the negatives? Because isn't negative 3 times negative 4 positive 12? Okay. Now is everybody happy? Everybody can do this, yeah? No matter what number I choose, we can figure this out, right? If I did 48, 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8, right? Everybody's good? Okay. Let's move it along. Now, we're not going to use algebra tiles. Get rid of that. I do want to draw this at least once, okay? When I say factor, it means break it down into groups, yes? Okay, so I have 6 x's, which if I draw them out would be 6 bars, yeah? And I have 3 little guys, which if I draw them out would be 3 little guys. Now the question becomes, how can I make a rectangle out of 6 and 3? What are my choices for making a rectangle out of 6? Do I have a rectangle right now? Right? Because I'm 1 thick and I'm 6 wide. So do I have a rectangle? What's my only other choice for 6? 2 and 3. Right? Okay. So this guy has to be either 6 and 1 or 2 and 3. Which one of those works with 3? 6 and 1 or 2 and 3? It has to be 2 and 3, doesn't it? Right? Everyone agrees? Okay. So it has to be 1, 2, 3. 1, 2, 3. 1, 2, 3. Hey, wait, that's not a rectangle. So what else can I do? If I do 3 and 2 and 1, 2, 3, am I in business now? Now I am, right? Now what are the factors? Where do the factors live? Once I've built my rectangle, the factors live outside, don't they? So what is this side? How long is this? 1x, yes? How long is this? 1x, yes? How long is that? 1. So this is 2x plus 1, yes? How long is this? 1. How long is this? How long is this? 1, 1, 1 for 3, right? So if I want the factors of 6x plus 3, that is 3, 2x plus 1, yes? And if I wanted to expand it, I would have to go this way, right? To get 6x plus 3. Now you guys should already see what we are doing here. What did I do to 6x plus 3 to get it factored? I divided it by what? 2? 3, right? Why did I choose 3? Because 3 will go into both of these, and it's the biggest one that will. Okay? So what I did here, this is what is called GCF, greatest common factor, factoring. And this should always be the first thing you try. Everybody cool? All right, so you've seen it with a picture. Now we're not going to do any pictures. We're just going to do it mathematically. Okay? So what I have is 4x squared plus 6x. Now, I want you to factor it, which means we must have to do some division, yes? So, step 1 in GCF factoring is decide on your GCF. What is it? What's the biggest number that goes into 4 and 6? 2. Excellent. So, look closer though. Right. Your GCF has to include your coefficients and all variables. Decide on your GCF. Got to include your coefficients and all your variables. So, Tavleen opened with 2, and upon second reflection, everybody said, oh no, wait, I got to think of the x. So our GCF here is 2x. That's what we've decided on, yes? That's our GCF. Step 2 is divide the whole thing by the GCF. So I take this and I divide by the GCF. All right? Step 3 is rewrite in the following form. GCF bracket, then all your quotients. Quotients. I'm not going to write it that way. Quotient 1 plus quotient 2 and so on. So, did we decide on our GCF? Yes. Have we divided by it? Yes. Have we done the third step? No. Let's do that. So the first thing I do is I write the GCF out here, and then I write all of my quotients. What is 4x squared divided by 2x? 2x. What is 6x divided by 2x? 3. And I'm done. Everybody cool? Okay. Now, this is one of those times where I'm going to do what all your previous math teachers did. And I'm going to stop at factoring. Next year, factoring is not the goal. Factoring is the first thing you do. The hardest question you do in this unit will become the first step of stuff you do next year. Okay? I'm going to show you where you go with this, but I'm not going to make you do anything with it, which is what makes it slightly different than grade 3, where you were taught something and then never saw it again until now. Everybody cool? All right. So, we are going to not look at... no, we are going to look at this right now. So what do I have there? I have a trinomial, yes? You guys already know from the beginning of this lesson, if a trinomial is going to factor, it's going to break down into 2 binomials, right? So, if I wanted to do this with a picture, and I'm going to use a picture, this is one of the only times I like the picture. If I am going to make this, I need this to make a rectangle, don't I? Right? All of this has to live in a rectangle, right? Well, that first one's real easy, isn't it? Why? There's only one of them, yeah? There's only one way I can put that in a rectangle, yes? 1 by 1. Everyone agree? So I know that one of my factors has to be an x, and the other one has to be an x. Cool? Right? Now, the other one that I have no choice with is this one, correct? Because I know that I got to multiply to 7, right? What are the only ways I can multiply to 7? 1 and 7. I have to have a rectangle of 1 and 7, yes? So I'm going to go ahead. I'm going to put 7 out here. 1, 2, 3, 4, 5, 6, 7. Agreed? Now I got to fill in the rectangle. How big is this blank? It's an X, isn't it? And this one, 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 and this one. That's 7 of them. I need how many? 8. Hey, 7 and 8 made a rectangle, right? Now, what's wrong with these 8 that I just drew here? They got to be negative. So they got to be shaded in, right? Everyone agree? Okay. So now what is each of these? Negative. And what's this guy? Negative. Because 2 negatives will give us a positive. Now, what are my factors? What's on the top? X minus 7. And what's on the side? What's over here? X minus 1. And now it's factored. Now, all of you, without me even telling you, should notice something. That's one of our shortcut ones, isn't it? And the numbers that went here were the numbers that multiplied to what? 7. And added to what?
8.
Negative 8. Remember how I said we had to think of all the factors? We're going to come back to that tomorrow, or possibly later today. But I want to spend some time with GCF to make sure everybody is on board. So you guys are going to do a bunch of these because, again, it's very important that you notice that it's the first thing you try. So greatest common factor, it's number 1. Why is it number 1? Because it's always the first move. You always try to do this. Always, 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 always. It's the first thing you need to see if you can do. And remember, you must check coefficients and variables. Because maybe there isn't a coefficient that works, but there are variables. Everybody with me? Now, quick reminder, what are the steps? 1, GCF. 2, divide. 3, rewrite. GCF bracket quotient 1 plus or minus quotient 2 and so on. That's all you got to do. Everybody understand? So we start with a super easy one. What's the greatest common factor? 5. So I decided on it. I divide by 5 and I rewrite. 5. Now my quotients. X plus 1. Yeah? Yeah. What about this one? We already did that one. We drew it. But now we're going to do it with just math. What's the GCF? 3. So I rewrite 3, 2x plus 1. Good? Okay. This guy. What's the GCF? 3. So I rewrite 3, and I get x squared plus 4x minus 2. Yeah? Okay. And finally, this one. 2x, because I got to check my variables as well. 2x plus 3. Is everybody good with GCF? It's literally 2 seconds, right? It's like grade 4 division. Except now you got to remember your exponent laws. Cool? Okay. It should take about a minute to do those 4. Are we done? What's the GCF in the first one? 5 x. Why is it only 1 x? I can see there's 2 there and 2 there, but there's only 1 there. Why is there no y? I can see a y there and a y there, because there's no y in the middle. Now I rewrite 5x, and I do all my quotients. What's the first one?
I put negative 6xy squared.
I like where you're going with that, Max. Max says his first term here has to be negative 6 xy squared. Why? Because it's got the biggest degree and the x is first. Then what should Max's second one be?
Plus 3x.
Plus 3x, because we're keeping with the x's. And then what?
Plus 5y.
Plus 5y. In a perfect world. Right? In a perfect world. Do I care that much? I'd be perfectly happy to have 5y plus 3x minus 6xy squared. Perfectly happy. Everybody cool? I don't think Mr. DeVries cares too much next year either. Your university profs, they're a little snootier. They might. Okay? My university profs didn't, because we were doing calculus and, you know. Okay, what's this guy? 2. So I could have 4 plus 5a plus 3a squared, right? But what should I have? 3a squared plus 5a plus 4, right? Yeah? Okay, what about this one? Whoo, barftastic. Now, hold up. What? Why negative 5? But it's supposed to be the greatest common factor. Is it negative 5 smaller? I'm not saying you're right or wrong. I'm just opening your eyes to something. If we choose negative, and Tavleen says we should because these are all negative, then I have negative 5. And what were your variables, Tavleen? CD. Because I only have 1 there, yes? So what would go out here? Negative 5 CD. And what would be in here? All these would go positive, wouldn't they? So it would be 4 C cubed, no D, right? Plus 6 C squared, 1D, yes? Plus 5. That's in the right order, right? But this isn't really our GCF, is it? Okay. Now, some people will say you want that negative 1 out of there. Because they're all negative, negative 1 is still a common factor. Do you understand what I'm saying? Everybody cool with that? But you could just as easily do this. Minus 4c cubed minus 6c squared d minus 5 depending on what your end game is. Okay? Does everybody understand what I'm saying? If we're going further with factors, you may want to do this. You may want to do this. The important thing to recognize here is you can do this. It is allowed to remove 1 anytime you want, either negative or positive, because 1 is a factor of every other number. Does everybody understand what I'm saying? You're about to see it either today or tomorrow when this will be useful to you. Okay? Now, what about this one? Is there anything to be done there? No. Okay? That is very important. This does not factor. I have watched kids on a test spend 15 minutes on a question that cannot be factored because they refuse to believe that it can't be factored because they are learning steps. So at the end of this unit, when I teach you 4 different kinds of factoring, they will sit there with a question and try to do all 4 without even once thinking that maybe it can't be done. Kind of like how when your teacher taught you to simplify fractions and gave you this and told you to simplify it. And you would sit there. Mrs. Bad Crumble, I don't know. Is it 2 over 8.5? Is it 1 over 4.25? I don't know. And you would do that, and Mrs. Bad Crumble would be like, no, here's a sticker. And then you'd be like, is it scratch and sniff? And she'd be like, no, because those are chemicals and those are bad. But if it was 1983, like when I was in Mrs. Bad Crumble's class, they were all scratch and sniff. It was wicked. Right? One time when I was teaching in a school, I went into the kindergarten class. We had a helium tank, so we were decorating the gym or something, and I went into the kindergarten class, and everybody was scared of me because I was the only male teacher in the school, even though I was only 21. And I went into the kindergarten class, and I looked really mad. Yes, 21. I graduated high school at 17 and went straight to university. Anyway, I went into the kindergarten class, and I had my really mean face on, but I'd sucked down a bunch of helium. And I started yelling at the kids, in that helium voice! And they all went ape. They loved it. They thought it was so funny. And then I got in trouble. Why did I get in trouble? Teaching the kids to huff. That's what that one teacher took out of it. Not that I was able to go and make some inroads with the kindergartners in the school that I was working at. That wasn't what was important. What was important was somehow I had created a bad influence on them, a bad example. But I was only 20. Actually, I lie. I was 22. Sorry. I just turned 22 a couple of months earlier. So, a school up by Williams Lake, very far away. All right, everyone is Gouda? Gouda. Please do page 150 and 151 and stop when you get to 4D. Yeah.